Hi, I'm Ed Murphy, professor and astronomer at the University of Virginia. It has been my pleasure to introduce generations of students to the beauty and wonder of the universe, including teaching a lecture series called Our Night Sky for the great courses. I invite you to join me now on the 50th anniversary of the very first moon landing for a guided tour of our moon, the Apollo landing sites, and a bit about what we learned from the Apollo missions. Most of us regularly see the moon in the night sky, but we don't stop to give it a second thought. We take a quick glance and we might note the phase of the moon. If it's full, we might look for the man in the moon or the rabbit in the moon. But the 50th anniversary of the Apollo 11 lunar landing is a great time to go outside and take a good long look at the moon and see it for what it really is. A complex world with complex geology and billions of years of solar system history written on its face. Through a small telescope or a pair of binoculars, the moon comes alive. You can see craters of all sizes, mountains, lava flows, and volcanic domes. Better still, through a moderate-sized backyard telescope, you can see how these are all related. You can discern the order in which they occurred, and you can see how one event affected another. Although a telescope will clearly give you the best view, there's still lots that you can see with a pair of binoculars or a spotting scope. If you have access to a telescope, you'll want to view the moon at many different magnifications. At low magnifications with a wide field of view, you can take in the whole moon and see it as a world. At moderate magnifications, you can view larger regions, such as the low-lying areas we call seas and the mountain ranges and their relations to one another. At high magnification, you can see the details in the craters, their central peaks, collapsed lava tubes, and individual mountain peaks. The moon can be bright, especially around the time of full moon. If you have one, you can use a neutral density filter to cut down on the brightness of the moon to make it more comfortable to view. But there are some things that you won't see. One of the most common questions I get when people are viewing the moon through a telescope is, can I see the flag on the moon? On a good steady night, a typical backyard telescope can see details that are 1 to 2 miles in diameter. That's about 1.5 to 3 kilometers in diameter. That is, the smallest thing you can see, which will look like a tiny little dot, is 1 to 2 miles across. Thus, you won't see the flags, the descent stages, nor the rovers that were left behind because they're much, much smaller than this limit. Even the Hubble Space Telescope can't see them. The smallest detail that the Hubble Space Telescope can see on the moon is about the size of a football field. To see things left behind by the astronauts, you need to bring your camera much closer to the moon by putting it on a satellite in orbit around the moon. NASA has done this with the Lunar Reconnaissance Orbiter, circling the moon just 12 to 100 miles above the surface. For example, there's an image of the Apollo 11 landing site showing the lunar module descent stage, the TV camera, the lunar ranging retroreflector, and the passive seismic experiment. You can even see the disturbed lunar soil where Neil Armstrong strolled over to peer into Little West Crater. In this lecture, we'll orient the moon as it appears to your naked eye, or in a pair of binoculars, for an observer at mid-northern latitudes. That is, it'll have lunar north at the top with lunar west to the left. If you are viewing the moon through a telescope, the moon may appear upside down and or left-right reversed, depending on how you are using the telescope. Keep that in mind as I talk about features on the moon. You may need to mentally flip or reverse the image. Finally, when I refer to north, south, east, and west, I'm referring to the cardinal directions as seen by an astronaut on the moon. These are not north, south, east, and west in our sky. Finally, you might wonder when is the best time to view the moon. Although you can see the whole near side of the moon around the time of full moon, it's not the best time to view many of the features on the surface. Around the time of full moon, the sun is behind us, and the shadows cast by the craters and the mountains are cast away from us, so we can't see them. It's these shadows that allow us to see the three-dimensional nature of the surface of the moon. So I recommend looking at the moon a few days before or after first quarter. During this time, the terminator, the line that divides day and night on the moon, sweeps across the center parts of the moon. Along the terminator, the sun is just rising, so the crater rims and the mountain peaks cast long shadows, making them easier to see and giving you a feeling of their height. If you watch the moon over the course of just a few hours, you can see the shadows change and shrink as the sun gets higher in the lunar sky. When you view the moon through a pair of binoculars or even with your naked eye, the dark, smooth seas, or maria, clearly stand out from the brighter, rougher highlands. It's these seas that make the man or the rabbit in the moon. Now, I have to be honest, I have a really hard time seeing the man in the moon. The rabbit is a bit easier for me, but it's upside down for those of us in the northern hemisphere. On the near side of the moon, the highlands dominate the northern and especially southern parts of the moon. The highlands are brighter in color than the maria. Binoculars or a telescope at low power will reveal that the highlands are heavily cratered, with craters on top of craters. These rough, heavily cratered highlands must have been exposed to space for long periods of time to build up this many craters. They are some of the oldest regions on the moon. By contrast, the maria, or seas, are much darker and smoother than the highlands. The smooth maria aren't really seas, of course. They are large, hardened lava flows that we now know flowed across the moon billions of years ago. They are dark in color because they are composed of basaltic lava, a lava common on Earth, the Hawaiian Islands, for example, that's nearly black in color. The maria have far fewer large impact craters superimposed on them because they're much younger than the highlands and they haven't been exposed to the bombardment from space for as long. If you look carefully at the maria, you'll notice that most of them are circular in shape, with mountainous regions around some sections of the rims. They're circular because the lava filled in giant circular impact basins. An impact basin is simply a giant crater on the moon, and most of these giant impact basins arose from collisions with giant asteroids or comets in the early history of the moon. Long after the basins formed, lava flowed up from underneath and filled in the low-lying areas. The mountainous regions around some sections of the rim are huge blocks of material that were uplifted in the impact that created the basin. That is, these mountain ranges are the giant rims of these enormous craters. If we look at the full moon, we can see that on the east side of the moon, there are four large, clearly defined seas. Fertility, Tranquility, and Serenity occur in a line connected together, while the Sea of Crises is on the northeast edge of the moon. The western side of the moon is dominated by the huge Ocean of Storms. In the central northwest, we find the round Sea of Showers, Mare Imbrium, one of the largest impact basins on the moon, with a diameter of about 750 miles, or about 1,200 kilometers. Now that we have our bearings, let's try to find the lunar landing sites. Apollo 11 landed in the southwest corner of the Sea of Tranquility in July of 1969. The best time for us to view the landing site is about 6 days past new moon. Before this time, the sun hasn't risen yet and the landing site is in darkness. Much later than this, the sun is high in the sky, making it more difficult to make out the features. To find the landing site, first locate the three large seas in a line on the east side of the moon. These are, from south to north, the seas of Fertility, Tranquility, and Serenity. The Sea of Tranquility is in the middle of the three seas. With your telescope or binoculars, find the Sea of Tranquility. In the southwest corner of the Sea of Tranquility, look for a pair of highland horns protruding into the sea. In the center of the horns is the 4-mile-wide crater Moltke, that's 6.5 kilometers across. The Apollo 11 landing site is on the flat lava plain, just north of the western horn and the crater Moltke. If you have a moderate-sized telescope and a night of excellent viewing, look for the three craters named after the Apollo 11 crew, Armstrong, Collins, and Aldrin, from east to west. Crater Armstrong is the largest of the three at about 2.8 miles in diameter. It will look like a tiny dot in your lens. Look also at the smooth sea. With the sun low in the sky, you should see numerous twisted, winding ridges called wrinkle ridges. These wrinkles formed in the hardened lava as it settled over the past few billion years. The Apollo 12 landing site in November 1969 is on the western hemisphere of the moon in the enormous Ocean of Storms, and it's best seen about 10 days after a new moon. To find the landing site in a telescope, find the great crater Copernicus, one of the most conspicuous craters on the moon. Proceed southwest from Copernicus, past the crater Reinhold to the 24-mile diameter crater Landsberg. South and east of Landsberg is the much smaller crater Frau Morrow B. The Apollo 12 landing site is on the plains, about halfway between Landsberg and Frau Morrow B. You might recall that Apollo 12 landed within walking distance of the robotic Surveyor 3 spacecraft, which landed in April of 1967. The Imbrium Basin was formed about 3.8 billion years ago when a giant asteroid, probably around 150 miles across, slammed into the Moon. In addition to creating a 750-mile-wide crater, it rained debris across the near side of the Moon. If you look at the central parts of the Moon, you will see extensive cratering and gouging that was caused by this debris. All of these gouges point back to the center of the Imbrium Basin, essentially pinpointing their origin. The damage caused by the ejecta from Imbrium allows geologists to determine whether certain features on the Moon came before or after the Imbrium impact. A crater or plain that shows scars from debris ejected in the Imbrium event must predate the creation of the Imbrium Basin. Craters that occurred after the Imbrium event don't show the distinctive gouging. Thus, determining the age of the Imbrium Basin was a primary goal of the Apollo 14 and 15 missions. Apollo 14 set down in January 1971 on the Frau Morrow Formation, just east of the Apollo 12 landing site. Since it's near Apollo 12, it's also best seen about 10 days past new moon, so look for the Apollo 12 and 14 sites at the same time. The Frau Morrow Formation is believed to be ejecta from the formation of the Imbrium Basin. Thus, a sample of this formation could tell geologists the age of the formation and the likely age of the impact that created the Imbrium Basin. To find the Apollo 14 landing site, go southeast from the crater Copernicus to the adjacent craters Bonpland and Perry. Both of these craters, 36 and 30 miles in diameter, show the destructive force of the ejecta from the Imbrium impact. They appear to be draped with ejecta, and their rims were gouged and cut by debris. Just north of the pair is the very degraded crater Frau Morrow itself, where the formation gets its name. The Apollo 14 landing site is on the rough terrain just north of the northern rim of Frau Morrow, north of the crater Frau Morrow D. The Imbrium impact and the lava that formed the resulting sea were so important that a second mission, Apollo 15, in July 1971, was dedicated to understanding this significant event in lunar history. Apollo 15 landed on the eastern edge of the Sea of Showers, on a lava plain called the Marsh of Decay, at the base of the curving Apennine mountain range. It's best seen about 8 to 9 days after the new moon. Here, the Apollo 15 astronauts, with the first lunar rover, could drive up onto the flanks of the mountains and sample material that may have come from deep inside the moon during the Imbrium impact. They could also sample the lava in the plains where they landed, and they could investigate Rima Hadley, a giant collapsed lava tube that is visible in a telescope on good nights. On the east side of the Sea of Showers, look for the giant 50-mile diameter crater Archimedes with its smooth lava-filled floor. From Archimedes, go southeast to the Apennine Mountains, the rim of the Imbrium Basin impact crater. Apollo 15 landed on the smooth lava plains at the base of Mons Hadley Delta. It was here, on the flank of Mons Hadley Delta, that the Apollo 15 astronauts found an ancient piece of the lunar crust called the Genesis Rock. Just across the plains towers Mons Hadley, a 14,000-foot tall mountain, about as high as some of the Alps on Earth. When the sun is low, Mons Hadley and Mons Hadley Delta cast spectacular shadows across the Marsh of Decay. The sinuous Rima Hadley snakes along the front of the Apennines. The Apollo 15 landing site is just east of the place where the rill takes a sharp bend away from Mons Hadley Delta. Until Apollo 15, all of the lunar missions had focused on the younger areas of the moon. With Apollo 16 in April 1972, for the first time, humans explored the ancient, heavily cratered highlands. About 7 days after the new moon, you can find the giant crater Theophilus on the western edge of the Sea of Fertility. Head west into the rough highlands, past the crater Kant, and try to find the small crater Daland. The Apollo 16 landing site was in the rough terrain just north and east of Daland. In the last mission to the moon, Apollo 17, in December 1972, the astronauts landed in the Littrow Valley in the far southeastern corner of the Sea of Serenity. This particular valley contains some of the darkest lava flows on the moon. When the moon is about 6 days past new, at the same time you're looking for the Apollo 11 landing site, go farther north to the area where the Sea of Tranquility and the Sea of Serenity seem to blend together. Just east of this joint, find a complex group of mountains and mountain peaks. The central peak of this area is called South Massif, and the peak just north of it is North Massif. The Apollo 17 landing site is immediately between the two peaks on the smooth lava plain. Though Apollo 17 was the last mission to the moon, NASA had planned and even built most of the equipment for Apollos 18 and 19. The landing sites for these two missions were never definitively decided, but there were a number of candidates considered. Two of the top candidates were the great craters Copernicus and Tycho, 56 and 52 miles across, respectively. These are two of the youngest large craters on the near side of the moon, and would have excavated material from great depths. They're visible 9 to 10 days after the new moon, and they're well worth exploring with a telescope. They are classic examples of large, complex craters with prominent central peaks, terraced rims, extensive ejecta blankets, and huge ray systems. Interestingly, Tycho is one of the more prominent features on the moon during the full moon, and its rays can be traced across the surface for over 1,000 miles. Another landing site that was considered was the Marius Hills, best visible about 12 days after the new moon, or just a few days before the full moon. Marius Hills is a complex set of volcanic domes on the western edge of the Sea of Storms, just west of the crater Marius. It will, likely, be one of the first places that we go when we return to the moon. This year, we are celebrating the triumph of ingenuity and determination that put men on the moon 50 years ago, the first and so far the only place outside of the Earth that humans have visited. The Apollo missions taught us a great deal, not only about the moon, but also about the Earth, the history of our solar system, our universe, and the human spirit of curiosity and wonder. Thank you for joining me on this tour of man's journeys to the moon and back.